Hello.
Hello.
Yeah. Do you have any questions?
Oh no, I'm good for this class.
Okay. Uh, Fine. So we had done a lot of theory about straight lines and all. Uh, a little bit is left, where I want to talk about. First thing is bisector equation for the angle between two straight lines. Two lines. The second thing is equation of a pair of straight lines. And then I want to move on to circle equations, circles. So we'll start off with this bisector. So what we mean by that is, if you have like two straight lines, so this line could be x plus y minus 5 is equal to 0, and this line is 2x minus 3y plus is equal to 2. Let's say these two lines will intersect at a certain point, right?
Yeah.
So we can find this point of intersection by just solving these two line equations, correct?
Yep.
Okay, so now obviously there is some angle here at the point of intersection. What we want to find out is the equation of the line, which is the bisector here.
Okay.
So this bisector line divides this angle into theta by 2 and theta by 2, and this equation we want to find out, equation of this line. Obviously there will be two bisectors because this angle is theta, then this is also the angle between the two lines, right? 180 minus theta. So
Yeah.
there is also another bisector which divides that bigger angle, right?
Right.
So, and you will realize that bisector 1 is perpendicular to bisector 2, right? Obviously, because since this is 180 minus theta, this is 90 minus theta by 2. So this is also 90 minus theta by 2, and this plus this is 190, right?
Yeah.
So the two bisectors are perpendicular to each other, and what we want to find out is equation of both of these bisectors. Okay.
Okay.
So the idea here is a geometric idea that any point lying on a bisector is going to be equidistant from the two straight lines. So what I mean by that is, if I have a point, random point here, P, right? If this
Yeah.
point P lies on the bisector, then I can drop a perpendicular to this line and drop a perpendicular to this line. We can prove that this has to be equal to this, right?
Yeah.
Because you can say that uh, triangle PTQ is congruent to triangle PQR.
Right.
Why is it congruent? Because it is first of all similar and one side is common. So it is similar because this is 90, this is 90, this is theta by 2, this is theta by 2, right?
Yeah.
And the common side is this common side, right? So that means the ratio of similarity is 1, therefore the triangles are congruent. And if the triangles are congruent, we get that PT must be equal to PR, right?
Yeah.
So how does that help us finding the equation of the two bisectors? It is obvious because if P is my x comma y now, right?
Yeah.
Then I can say that I have learned how to write distance from point P to line this one, right?
Yeah.
So I can say the distance from xy to this line would be 2x minus 3y minus 2 mod by root over 2 square plus 3 square, right?
Yeah.
And that should be equal to the distance from xy to this line, which will be x plus y minus 5 by root over 1 plus 1. Correct?
Yeah.
This is just saying that distances are equal, right? So
Yeah.
what we get now is we can write this as 2x minus 3y minus 2 by root over 4 plus 9 13 is equal to plus minus x plus y minus 5 by root 2. Here I have removed the mods and I have written it as plus minus because both the signs could happen, right?
Yeah. Yeah.
If you remove the mod, you'll have to put both the signs possible because it is not necessary that both of them are positive at the same time or something.
Yeah.
So this actually, if you think about it, this is two separate equations, right?
Yeah.
Two separate equations, and each equation represents one of the bisectors. Because the rule that a point lying on the bisector is equidistant from the angles, the sides making up the angle, is valid even for a point lying here, right? This would also be equidistant from this and this. Because this line is also a bisector of this particular angle, right?
Yeah.
So you get equations of both of the bisectors like this. So in general, if you have two lines like this, let's call this first line a1x plus b1y plus c1 is equal to 0. And the second line is a2x plus b2y plus c2 is equal to 0. Then equation of the two bisectors will be given by equations of the two bisectors will be a1x plus b1y plus c1 by root over a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 by root over a2 square plus b2 square. Okay,
Okay.
are you understanding how and why this is happening?
Yeah.
Okay, now what I want you to try and figure out is how will you decide how will you decide which of these two bisector equations represent the acute angle bisector. Like we know that if two lines intersect, this angle could be either acute or obtuse, right? Like it could be, this angle could be less than 90 or it could be greater than 90, right?
Yeah.
So I don't know which bisector is the acute angle bisector. I mean, from the figure, I know if this is less than 90, then this is my acute angle bisector, right?
Yeah.
And this is my obtuse angle bisector. However, from the equation, we don't get that information. Like we don't know whether we should take plus sign or minus sign for acute angle bisector, right?
Yeah.
So what I want you to tell me is try to think of a way in which we can decide which sign to put for the acute angle bisector, which sign to put for the obtuse angle bisector. Or in general, you don't need to come up with a rule. You just need to tell me, like, if given two lines, how will you figure that out? Which sign is acute angle bisector, right?
Yeah.
Think about that. Okay. Any ideas? So what you can do here is, let's say we have some equation, right? We have one of these equations.
Yeah.
So take any equation, like take the plus sign, for example. A1x plus b1y plus c1y root over a1 square plus b1 square is equal to plus a2x plus b2y plus c2 by root over a2 square plus b2 square. If we take the plus equation, right now we don't know whether this one is this or this. That is what our confusion is, right? Correct.
Yeah.
So what you can do is, this is a line equation. You realize that it is a line equation because denominator is a constant, and you can bring all the terms on one side and simplify and make it something in x plus something in y plus something in c, right?
Yeah.
You can simplify it if you have some data, some numbers, you can put it on one side, right? So
Yeah.
so find the angle between this line, angle between this line
Yeah.
and any one of the given lines, like let's say a1x plus b1y plus c1, right?
Yes.
How do we find the angle between two lines? We take the slopes and we say tan theta is equal to m1 minus m2 by 1 plus m1 m2, right?
Yeah.
This m1 is the slope of this line, m2 is the slope of this line, and you do this, you'll get the angle between the two lines, right?
Yeah.
If your tan theta is greater than 1 here, then
Yeah.
that means that the angle theta is greater than 45, right?
Yeah.
So if my theta angle is greater than 45, then this must be obtuse angle bisector, no? Angle between this and this is greater than 45, right? Because if this is greater than 45, then this total angle is greater than 90, right?
Yeah.
You understand?
Yes.
So basically pick one equation, find the angle between that bisector equation and the line equation. And once you have found the angle, you will know whether it is greater than 45 or lesser than 45. If it is lesser than 45, then what you picked was an acute angle bisector. And if it is greater than 45, whatever you picked was an obtuse angle bisector, right?
Yes.
So in general, this is how you find the bisector equations. Uh, and this is just an application. Sometimes in problems, you might get a situation where you have a parallelogram and you want to find the diagonals and so on, right? Or not a
Yeah.
parallelogram. Parallelogram is not necessary that it will be half-half, but
Yeah.
in a square, it is necessary. So, or uh, so you want to find out, say, this angle. You might be given this
Yeah.
line and this line, and you want this line. So you can use the bisector equation to just get the line equation, right?
Yeah.
So you can see applications of this in problems. It might not immediately be useful, but just know how to do it. The way we do it is by using the geometrical property that a point
Yeah.
lying on a bisector is equidistant from the two lines, right?
Yeah.
Okay, then what we'll look at next is pair of straight lines equation, the algebraic equation of a pair of straight lines. So this is
Yeah.
the first time that we will see a 2-degree equation in x and y.
Okay.
2-degree equation in x and y. Uh, and now onwards, we'll be studying 2-degree equations, because 2-degree equations can represent all of the things that we need to understand in analytic geometry. So basically, it can represent pair of straight lines, it can represent circles, it can represent parabolas or hyperbolas or ellipses.
Yeah.
So eventually, like, when we finish all of this, we will learn like when, like I'm just writing a general 2-degree equation in x and y. So it looks like this: 2gx
Yeah.
2fy plus c is equal to 0. Here, this equation a, h, b, g, f, c are constants.
Yep.
So notice that this term is degree 2, this term is degree 2, this term is degree 2, and there are degree 1 terms also, and there is a constant term, right?
Yeah.
So this is the most general 2-degree equation in x and y. The reason there are some 2's, 2 here, 2 here, and 2 here is because it makes the final equation simpler. Like someone could even write an equation like this, that is also valid. If you write it like this, that is also a correct 2-degree equation. There's no issue. It's just that your final circle equation or parabola equation will come a little more awkward. So we are just writing the constant as 2h here, 2g here, and 2f here. Okay.
Yeah.
So this is a standard 2-degree equation in x and y, and we will see as we study further that this equation can sometimes be equation of a pair of straight lines, sometimes it can represent a circle, or sometimes all of these things, right? So what we will need to understand is when is this equation going to be a straight line, when is it going to be a circle, when is it going to be a parabola, ellipse, or hyperbola, right?
Yeah.
So, okay. So first thing we will begin with is very simple. Let's say we have two lines that pass through the origin, right? One line is y is equal to, let's say, m1x, and the other line is y is equal to m2x, right? Okay.
Yes.
So obviously these are two straight lines that pass through the origin because the constant term is 0 here, and 0 comma 0
Yeah.
basically lies on both of them. So if I wanted to write these two lines in terms of one equation, basically what I mean to say is I want one equation which represents both these lines, right?
Yes.
Both these lines, then what would I do? What I can do then is write this equation can be written as y minus m2x is equal to 0, and the second equation is y minus m1x is equal to 0. And what you can do is multiply both the equations and say that it is equal to 0. Now this thing basically has two factors, and the equation y minus m1x multiplied by y minus m2x is equal to 0 will be satisfied when either of the factors is 0, right? Correct.
Yeah.
This combined equation will be satisfied when either one of the factors is 0, right? So if one of the factors is 0, that means the point lies on that particular line, right?
Yes.
If y minus m1x is 0, I know that xy lies on this line. And if y minus m2x is 0, I know that xy lies on this line, right?
Yes.
So by writing the combined equation as a product of these two, I am saying that any point lying on either of those two lines will satisfy this overall equation, right?
Yes.
So obviously, that means that this overall equation represents the equation of the pair of straight lines, right?
Yeah.
Because only the points which lie on either of the two lines will satisfy this equation. Any other point will not satisfy this equation because any arbitrary point here will not make either of the factors 0, right? Correct.
Yes.
Okay. So if you have two lines that pass through the origin, which are y is equal to m1x and y is equal to m2x, then my combined equation of the pair of straight lines is simply y minus m1x multiplied by y minus m2x is equal to 0, right?
Yeah.
If you multiply this out a little bit, uh, you will get this y square minus m1 plus m2 xy plus m1 m2 x square is equal to 0, right?
Yes.
So we will rearrange it and write it like this: m1 m2 x square plus y square minus m1 plus m2 xy is equal to 0, right?
Yeah.
And now we will look at our general equation: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, right?
Yes.
Now notice that in this general equation, there were some 1 degree and 0 degree terms also, right?
Yeah.
However, in our equation here, there are no 1 degree or 0 degree terms. All the terms are 2 degree, right?
Yeah.
There is x square, y square, and xy, three terms, and all the terms are second degree terms, right?
Yeah.
So this type of an equation where every term is of the same degree is called a homogeneous equation. Homogeneous equation of degree 2, this is, right?
Yeah.
Homogeneous equations are those where every term has the same degree. This is not a homogeneous equation, this one, because there are some first degree terms and some constant terms, right?
Yeah.
So what we know right now is that if you have a homogeneous equation in 2 degrees, then it is likely that it represents a pair of straight lines passing through the origin, right? Correct.
Correct.
Because notice that pair of straight lines passing through the origin gives you a homogeneous 2 degree equation when you multiply them, right? Correct.
Yeah.
So
Yeah.
what we need to have for it to be to pair of straight lines passing through the origin, we should have g is equal to f is equal to c is equal to 0 first of all. These terms should vanish, right?
Yeah.
So the standard equation of a pair of straight lines passing through the origin will look something like this: ax square plus 2hxy plus by square is equal to 0, right?
Yes.
This is standard equation of pair of straight lines through the origin. Pair of straight lines through 0 comma 0. Now, if I compare the coefficients here, if I compare from this equation and this equation, if you compare the coefficients, what you will realize is I should divide by b to make the coefficient of y square to be 1, right?
Yeah.
So I will get a by b x square plus 2h by b xy plus y square is equal to 0, right?
Yeah.
And this equation represents a pair of straight lines, and we'll compare these two, and we can say that m1 m2 should be equal to a by b, and m1 plus m2 should be equal to minus 2h by b, right?
Yes.
So this is a very useful fact, because what it is saying is, as soon as you have an equation that looks like this, automatically you know the slopes of the lines that are involved, because you can directly write m1 m2 as 2h by b, and m1 m2 as a by b, and m1 plus m2 as minus 2h by b, right?
Right.
And then if you know product and sum of two things, you'll be able to find individual things, right? m1 and m2 you can solve here, because you can find m1 minus m2 now, right?
Yeah.
Are you understanding? You can just do 4h square by b square minus 4a by b, right?
Yes.
And root of that will be m1 minus m2. Once you have m1 minus m2 and m1 plus m2, you can add and solve, and you'll get m1 individually and m2 individually, right?
Yeah.
So what we are seeing here is that our equation ax square plus 2hxy plus by square is equal to 0 represents two straight lines passing through the origin, two straight lines passing through 0 comma 0 through 0 comma 0 with slopes m1 and m2 such that m1 plus m2 is equal to minus 2h by b and m1 m2 is equal to a by b. Okay,
Yeah.
you should write this down, this is quite important. uh, like right now the way we got it was by doing what we saw the other equation y minus m1x, other version of it, y minus m2x is equal to 0, and we multiplied this out and then we compared the coefficients, right?
Yeah.
We could have gotten this in a slightly different way also, probably a more convincing way, where what we will say is look at this equation and I will solve this equation, solve this as a quadratic in y, quadratic in y. Notice that there is a y square, there is a y, and there is a no y term, right?
Yeah.
You can say that this is by square plus 2hx into y plus ax square is equal to 0, right? Correct.
Yes.
So
Yeah.
by quadratic formula for y, thinking of y as the variable and everything else as coefficients, you can say y should be equal to minus of 2hx plus minus root over 4h square x square minus 4abx square by 2 into b, right?
Right.
So here 2 will cancel throughout, x will come out from x square, and you will get minus hx plus minus x into h square minus ab by 2, 2 cancels, so just b, right?
Yeah.
So notice that you can write it as minus h plus minus root over h square minus ab by b multiplied by x, right?
Yes.
So now notice that the equation has become y is equal to some constant into x, right? Correct.
Yes.
So that is an equation like y is equal to m1x and y is equal to m2x, and m1 can be your plus, m1 can be minus h by b plus root over h square minus ab by b, and m2 can be minus h by b minus root over h square minus ab by b, right?
Yeah.
And so obviously now it is clear that this is a straight line equation which passes through the origin, right? It's y is equal to m1x and y is
Yeah.
equal to x. And if you add up m1 plus m2, see, add up m1 plus m2, you get minus 2h by b, right?
Yeah.
And if you multiply m1 and m2, you will get h square by b square minus h square minus ab by b square, which will give you ab by b square, which is a by b. You can multiply and check, it will come a by b, m1 into m2, right?
Yes.
So basically now we have proved by algebra and solving it that this definitely represents two straight lines, y is equal to m1x, y is equal to m2x. The slopes of the two straight lines are m1 is minus h by b plus this thing, m2 is minus h by b minus that root thing, right?
Yeah.
However, in actual questions, you don't need to always solve it like this. Here we applied the quadratic formula and solved it. You can directly now say, if you remember these two results, you can directly say, oh yes, this is a homogeneous equation in 2 degree, so it must be a pair of straight lines passing through the origin, and therefore I know m1 plus m2 should be minus 2h by b and m1 m2 should be a by b, right?
Yeah.
So remembering these results gives you the line equations instantly. Like you just have to solve these two to get m1 and m2, right?
Yeah.
Okay. So this was the easy case. This was the case when the two straight lines were passing through the origin, right?
Right.
One more thing here that we can find here is what is the angle between these two straight lines? The angle between these two straight lines should be tan theta is equal to m1 minus m2 by 1 plus m1 m2, right?
Yeah.
And we already know m1 m2 is equal to a by b, and m1 plus m2 is equal to minus 2h by b. So therefore, m1 minus m2 will be equal to root over m1 plus m2 whole square minus 4 m1 m2, which becomes
Yeah.
root over m1 plus m2 whole square is 4h square by b square minus 4 times m1 m2, so 4a by b. So that becomes root over 4h square minus 4ab by b square. So b comes out, and this becomes m1 minus m2 is equal to, we can write it as 2 times root over h square minus ab by b, right?
Yeah.
So the top part is that 2 times root over h square minus ab by b, and 1 plus m1 m2 is 1 plus a by b, right?
Yes.
So what we get now is 2 root over h square minus ab by a plus b, right? Is tan theta,
Yeah.
correct?
Yes.
So now our lines are y is equal to m1x, y is equal to m2x, and the angle between the lines is theta, and that tan theta is coming by this. So if a plus b is equal to 0, right, then tan theta is tending to infinite. So theta is tending to 90-degree, right?
Yes.
So basically, if I have the equation ax square plus 2hxy plus by square is equal to 0, I know it represents two straight lines. The information that I know is slope of the lines can be m1 plus m2 should be minus 2h by b, m1 m2 should be a by b. The angle between these two straight lines will be tan theta is equal to 2 times root over h square minus ab by a plus b. And if a plus b is equal to 0, the lines are perpendicular to each other, right?
Yeah.
Because then your tan theta has become infinite, right?
Yes.
So this information, this is what you need to know for pair of straight lines passing through the origin. Okay, so
Yes.
that you write it down, and if you have any doubts, if you have not understood something, just ask now only. The way we got the equation, you can get the equation by solving the quadratic in y, right?
Yeah.
To solve the quadratic in y, you will get the individual line equations, because it will come out to be y is equal to something minus h by b plus minus root over h square minus ab by b multiplied by x. This will be your two lines.
Yeah.
Okay, so have you written this down, whatever we have written so far?
Yeah. Just 1 minute.
Yeah. all of these things, by the way, you can find in SLONI chapter number 6. Okay.
Okay.
So you should, if you are having any doubts, you should go to SLONI chapter 6 for all of this stuff. Have you written?
Yeah.
Okay, so now what we will discuss is, in general, equation of a pair of straight lines. Straight lines. Now they don't need to pass through the origin. Okay. They don't need to pass through the origin. So previous case was a special case when they were passing through the origin, both of them, right? Now,
Yeah.
in general, if you have two lines which don't have to pass through the origin, they can look like this: y is equal to m1x plus c1 and y is equal to m2x plus c2, right?
Yeah.
So if I want the equation of the pair, I will multiply both those equations together, right? Like this. This will be the equation of the pair of straight lines here, right?
Yeah.
And now you will realize that when you multiply, you will get degree 2, degree 1, and constant terms. All types of terms will come now, right?
Yeah.
Degree 1 term will be, for example, c1 into y, or m1x into c2, right? And constant term will be c1, c2. Correct?
Yeah.
So in general, the equation here will look something like this: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Like,
Yeah.
there will be all types of terms in this equation of a pair of straight lines. Now what we need to do is we need to figure out that, given if someone gave us this general 2-degree equation, can we find out that it is a pair of straight lines or not? Or what is the condition? What is the condition that must be true for this equation to be a pair of straight lines? Correct?
Yeah.
Because in the exam you will get some equation with some numbers, and they might not even tell you what that represents. You have to figure out whether it is straight line or circle or whatever, right?
Mhm.
So how do we think about this? So we will use the same strategy that we did in the previous question. Are you
Yeah.
hearing me? You're able to hear me, right? So in the previous question, remember, we had only 3 terms, these 3 terms, and then we solved the quadratic in
Yeah.
it, right? Now we have many more terms. We have 6 terms, but still you can write this like this: by square plus 2hx plus 2fy plus ax square plus 2gx plus c is equal to 0, right?
Yeah.
So notice that now it is still a quadratic equation in y. So I can still solve it for y. I can say y is equal to minus of 2hx plus 2f plus minus root over b square, which is 4hx plus f whole square minus 4b ax square plus 2gx plus c divided by 2 times b, right?
Yeah.
Now we can cancel off 2 from everywhere. 4 will go away, 2 will go away here, and 2 will go away here, and you have minus of hx plus f plus minus root over hx plus f whole square minus b into ax square plus 2gx plus c divided by b, right?
Mm.
So right now we still don't know what we'll do now, because the problem is that there is some square root, and that square root is not disappearing very easily. The square root has x terms and all, right?
Yeah.
So think about it. When can we say that this equation that we have gotten here in this step is a straight line equation? When it should have a linear power in x, right? X should have power 1, right?
Yeah.
Like y and x both should have power 1, right? Y already has a power 1 here, and x has a power 1 here, but here there is a problem. It is under a root, right?
Yeah.
So we are saying that for this equation to represent straight lines, to represent a pair of straight lines, you must have that the thing inside the root should be removed, no? Root
Yeah.
should be removed in some way, should be removed, and x should have power 1. X should be linear, correct?
Yes.
Power should be 1. So the only way that happens is if the thing inside the root, the quantity inside the root should be a perfect square, right? Inside the root is a perfect square. How? Like if the quantity inside the root is some px plus q whole square, then when you put it under the root like this, minus hx plus f plus minus this by 2b or something, if the inside part was some px plus q whole square, I would just solve it like this, minus hx plus f plus minus px plus q, right, by b.
Yeah.
And then you get two separate equations, which are the equations of your two lines which make up that pair, right?
Yeah.
Notice that if you write the equation separately, you'll get y is equal to minus h by b plus minus p by b x plus f plus minus q by b, right? This is what is y.
Yeah.
And since this is plus minus, there are two actual equations. One is the first line, the second one is the second line, right? Correct.
Yeah. Yes.
And now here we had assumed that the inside part can be written as px plus q whole square. So let's think about that for a moment. Like when will it be a whole square of px plus q, right?
Yeah.
For that to happen, this first term should be px whole square, right? Px whole square. No, we'll not do it right away. We'll first simplify this thing inside the root a little bit. So what I will say is y is equal to minus of hx plus f by b plus minus 1 by b root over. If we expand this, you will realize that it is h square minus ab into x square plus f square minus bc plus 2hf minus 2bgx plus f square minus bc, right?
Yeah.
Now this quantity is a quadratic in x, and it will be equal to px plus q whole square if b square is equal to h square minus ab, q square is equal to f square minus bc, and pq is equal to hf minus bg, right?
Yeah.
Because then you can say that it is p square x square plus 2pq at x plus q square, right?
Yes.
So now if you notice these three things, now you can immediately write a condition, because your condition will be something like this. You will say p is equal to root over h square minus bc, and q is equal to root over f square minus bc, and you get the condition root over h square minus ab multiplied by root over f square minus bc should be equal to hf minus bg, right?
Yeah.
Then only this pq matches what we should get here, right?
Yes.
Squaring this, you get h square f square minus h square b minus ab f square plus ab square c is equal to h square f square plus b square g square minus 2f hbg. And notice that h square f square gets cancelled, and in all the terms there is a b. Every term remaining has a b. I can cancel one b then, right?
Okay. Yeah.
What you are left with is this condition. Here also there is a b that is cancelled. You're left with minus ch square minus af square plus abc is equal to bg square minus 2fgh, right?
Yeah.
So the condition that we want is this condition abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. This is how the condition is written in normal way. So we are saying that this is a condition on the coefficients of the degree 2 equation in x and y, and if the coefficients are not satisfying this condition, then you will not be able to take this as a perfect square, and you will not be able to make a root out of it, right?
Yeah.
So what have we learned so far? What we have learned is this general equation plus by square plus 2gx plus c is equal to 0 has to satisfy the condition abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. Okay.
Okay.
If this is 0, then the equation, above equation, is a public pair of straight lines. Pair of straight lines. Correct?
Yeah.
Do you remember how we got this? No, we solved a quadratic in y and said that the thing inside the root should be a perfect square, right?
Yeah.
And the thing inside the root was having a form px plus q something. So we can just say that if your p was equal to root over h square minus bc, h square minus ab, and your q was equal to root over f square minus bc, then pq, you multiply it out and you get this condition. Then pq should be equal to both versions of it. So why is this important? It is important because now at least you can look at a curve and find out a b c f g h and find out the value of this thing, right? Then
Yeah.
you will realize that since the same equation can represent 5 different types of curves, it is important to be able to distinguish between them, right? So
Yeah.
same equation can also be a circle. So therefore, right now it is not a circle. Right now it is a pair of straight lines because this condition is being satisfied. Okay.
Yeah.
Then you will notice that the old equations for m1 plus m2 is equal to minus 2h by b and m1 m2 is equal to a by b are still valid, even if the straight lines do not pass through the origin. Okay.
Yeah.
Why is it still valid? Because remember, when we solved it, we got something like this: y is equal to minus b. Minus b term here would be 2 hx minus fy, I think. Hx plus
Yeah.
f. So minus hx plus fy plus minus px plus q, right? By 2 into b, 2 into b, yeah, correct.
Yeah.
So, and p was what? P was equal to root over h square minus ab, correct. So
Yeah.
what we get here is slope is minus p by 2 minus h by 2b plus minus p by 2b, correct.
Yeah.
So now notice that if you do m1 is the plus sign and m2 is the negative sign, then we can say that m1 plus m2 will be equal to what? M1 plus m2 will be equal to, here we have this minus h by 2b plus minus p. Huh. So obviously it is equal to, is there a 2 here? There was no 2 here, no, just it was b. Thing. Just b it was. So it will be equal to this plus this. So it will be again minus 2h by b. Why? Because notice that minus h by b is there in both, no, plus minus will cancel, right?
Yeah.
And again you're getting m1 m2 will be equal to a by b, because you'll get h square by b square minus p square by b square, right?
Yeah.
B square is h square minus ab, right? So it will become ab by b square.
Yes.
So the idea here is just that you need to be able to write this condition for the equation in 2 degree to be a straight line, pair
Yeah.
of straight lines. Then in pair of straight lines, there is nothing much else that is there to learn. The ideas we have just now covered. Sometimes you might get equations like this. So let's say we have an equation x cube plus a x square y plus b x y square plus d y cube is equal to 0, right?
Yeah.
So now, first thing to notice here is that this is a degree 3, degree 3, degree 3, degree 3 terms, right?
Yeah.
So homogeneous third degree equation, homogeneous third degree, then okay, homogeneous third degree equation. Huh, then I want to find the equation of the 3 lines that make up this equation, right? Make up this equation. So what you have to realize here is that uh, the 3 lines that make up this equation will all pass through the origin. All lines will pass through origin, because you can see here that this equation is homogeneous. So same principle as before. All lines will pass through the origin, and the 3 equations that make up this equation, this overall equation, can be obtained by solving for y. And the way you can solve for y here is first divide by x cube. So you get 1 plus a into y by x plus b into y by x whole square plus d into y by x whole cube, right?
Yeah.
And we can say that the equation of the line should be y is equal to m1x, m2x, and so on. Therefore, y by x is equal to this thing, m1 Y by x is equal to either m1 or m2, right? You can call that
Yeah.
as m, the slope. So your equation becomes dm cube plus bm square plus am plus 1 is equal to 0, right?
Yeah.
Now, this equation can have 3 real roots or 1 real root. Cannot have 2 real roots, because then that will mean imaginary root is only 1, which is not possible. 3 real roots. So what we can say by Vieta's relation, the equations will have solutions m1, m2, m3, and m1 plus m2 plus m3 should be equal to minus b, right? Minus b by a, right? Correct.
Yeah.
And you have some of the slopes taken two at a time, m2, m3 plus m3, m1 is equal to a by is equal to c by a d, right? Correct. And m1, m2, m3, the product, m1, m2, m3 will come out to be minus plus minus, so minus 1 by d, right?
Yeah.
So even if the question is not directly a 2-degree equation, we can use common sense and figure out if it represents 3 straight lines passing through the origin. If that, then you can just divide by x cube and write I is equal to mx. And then you basically have a situation where you have multiple roots for that m, and we can find out m1, m2, m3 by the 3 Vieta's relations. That is possible to do. So now this pair of straight lines, more or less the ideas are covered. What we need to do is do some questions. So look at chapter 6. You have the book with you right now? Do you have the book? Hello? You have the book with you right now? Hello? Can you hear me? Hello?
Oh yeah. Yes.
You have the book now with you?
Oh yeah. I know.
Okay, so page 97. Page 97. This is exercise number 14. Exercise 14. This is in chapter 6. Okay. What I want you to do is try to do question number
Yeah.
uh, question number 3, question 23, uh, Question 323. Question 1 and question number, let's do one more. 19. These 4 questions. Okay.
Yeah.
So if we can solve, like if we can solve exercise 14 more or less like straight lines and all, then we know enough. We know everything that is needed. So let's try these 4 questions. You try them. You can try in question 1, question 3 order. 5-10 minutes. Just give it a try. Okay, so question number 1, for example. Question 1 is saying, prove that the equation y cube minus x cube plus 3xy y minus x is equal to 0 represents three straight lines which are equally inclined to one another, equally inclined to one another. That means the angle between any two of them is the same, right?
Yeah.
So first of all, we have to find the three line equations. So we have to somehow solve this and find the line equation. So what you can do is quickly factorize this. This first part is y minus x, y square plus xy plus x square plus 3xy y minus x is equal to 0, right?
Yeah.
You can take y minus x common here and it will become y square plus 4xy plus x square, right?
Yeah.
So obviously one of the lines is y is equal to x, this one, right?
Yeah.
The other two lines will come if we solve this quadratic. So if we solve the quadratic, y square plus 4xy plus x square is equal to 0, you will get y should be equal to minus your b is 4x, so minus 4x plus minus root over b square, so 16x square minus 4 times a is 1, c is x square by 2 into 1, right?
Yeah.
You will get minus 4x plus minus root 12x square. So that will be plus minus 2 root 3x by 2. So your line equations are y is equal to minus 2x plus minus root 3x, right?
Yeah.
So the two line equations are y is equal to root 3 minus 2 into x and y is equal to minus root 3 minus 2 into x, right?
Yes.
So three lines are y is equal to x, y is equal to this, and y is equal to this, right?
Yeah.
Okay, great. So now we know the three line equations. So first part is proved that they represent three straight lines. Now we have to show that they are equally inclined from one another. So to show that, we can say slope of this line is 1, slope of this line is root 3 minus 2, and slope of this line is minus root 3 minus 2, right?
Yeah.
And find the angle between any two of them, right? So in order to
Yeah.
find the angle between any two of them, we just need to do tan alpha 1 is equal to m1 minus this by 1 plus m1 m2. And similarly, you will do. So what I will do is I'll do one or two calculations here. So we will get tan alpha will be equal to, let's say the angle between this and this will be m1 minus m2, 1 minus root 3 plus 2 by 1 plus m1 m2. So root 3 minus 2. So this is becoming 3 minus root 3 by root 3 minus 1, right? So notice that tan alpha, you take root 3 common here, you will get root 3 minus 1. So cancels out, right? So alpha is 60 degree here, right?
Yeah.
The angle between them is 60 degree is coming, this and this. And similarly, let's find the angle between this and this. So you will get tan alpha is equal to 1 minus that. So 1 plus root 3 plus 2, right? By
Yeah.
1 plus m1 m2. So 1 minus root 3 minus 2. So this is 3 plus root 3 by minus 1 minus root 3. So this is minus root 3, right?
Yeah.
So again, this is a 60 degree angle. It's just that it is minus 60 degree. So that is because the order, we don't know how they are arranged, right?
Right.
Like one of them could be like this and like this. Then you say this angle is minus 60 and this angle would have been called 60, right?
Yeah.
So you can find the angle between this and this also, and you will again get 60 degree. So all the three angles will come out to be 60. So This is what we have proved. We have proved that the straight lines are equally inclined to one another, right?
Yes.
Let's, for example, take the third question. Third question says, show that the straight lines are a square minus 3b square x square plus 8ab xy plus b square minus 3a square y square is equal to 0. Form with the line ax plus by plus c is equal to 0, an equilateral triangle. They form an equilateral triangle with this line, and the area of the triangle is c square by root 3 a square plus b square. So we'll come to the area part later. First, let's see whether they form an equilateral triangle with this line. So again, the idea is this is a pair of straight lines. No, it's a 2-degree equation, right?
Yeah.
So this is a pair of straight lines. So we should find the individual straight lines. We can find it by trying to solve for y in terms of x, right?
Yeah.
So b square minus 3a square y square plus 8abx into y plus a square minus 3b square x square. This is my equation. And if I solve this for y, I get y is equal to minus b. Minus b is minus 8abx plus minus root over 64 a square b square x square minus 4 times this
Yeah.
this constant is b square minus 3a square, and this thing which is a square minus 3b square x square by 2 into b square minus 3a square. Just we'll simplify this. Just hold on for a second.
Yeah.
Okay, so simplifying this a little bit. Uh, okay, so x square is here, so x will come out, and you will have minus 8abx plus minus x, and inside you have this expression. And let's multiply it a little bit. We get a square b square minus 3b power 4 minus 3a power 4 plus 9a square b square. So you get 10a square b square, right? 10a square b square minus
Yeah.
b power 4 minus 3a power 4, and then you have to multiply that by 4. So you get minus 40 minus 12 minus 12, right? So you will get 64 minus 40. So that will be 24 a square b square minus 12 b power 4 minus 12 a power 4, right? Something like this.
Yeah.
So this is basically, you can take 4 common from here, and 2 will come out here. Have we done the multiplication correctly? Yeah, it's correct only, I think. B square a square minus 3a power 4 minus 3b power 4 plus 9. Yeah, 10 will come, and minus 4 minus 40, so plus 24 minus this. Okay, so this thing, you can take 4 common, so you get 6a square b square minus 3b power 4 minus 3a power 4, and 2 comes outside here, and root of this, root of this. So this doesn't seem like a perfect square. Wait, we could have taken 6 common also. So 3 can also come out common. And you'll get b power 4. Okay, this is a perfect square. But it is negative, right?
Yeah. Yeah.
Problem is that it's negative. That is the weird part. Let me just check the equation. Have we made some copying error? A square minus 3b square plus 8ab xy plus b square minus 3a square y square. We are solving for y plus a square minus 3a square x square. Okay. So why is this coming negative? Negative square is coming. That is totally weird. Minus b square minus a square whole square. Okay, I will try something else. A square minus 3b square x square plus 8ab xy plus b square minus 3a square y square is equal to 0. I want to factorize this. I want to factorize this. So we have this part can be written as a plus root 3b x multiplied by a minus root 3b x, right? Correct.
Yeah.
And we have minus 3a square minus b square y square plus 8ab xy is equal to 0. And I will write this also like this: a plus root 3b x a minus root 3b x minus root 3a minus b y and root 3a plus b y plus 8ab xy, right? It's the same thing, right? Correct.
Yeah.
Now what happens when we multiply this and this? We get 3 root 3a square. Like, how do we account for this 8ab xy term? Okay. Root 3a minus b, root 3a minus by multiplied by a minus root 3bx What is that equal to? That is equal to xy and root 3a square minus 3ab minus ab plus root 3b square, right? And if you multiply root 3a plus b into y with negative of a plus root 3b x, you will get again xy, you will get minus root 3a square plus 3ab, no, minus 3ab, minus 3ab and minus ab and minus root 3b square. Okay, okay. Now notice that this plus this, if you add these two, what you're getting is root 3a square will cancel this, root 3b square will cancel this, and you get minus 4ab minus 4ab minus 8ab, right? Correct.
Yeah,
Correct.
correct.
You'll get a minus 8abxy. If you add this and this, so basically what we are getting is uh, this quantity. So if you do a minus of root 3a minus b y into a minus root 3b x minus plus this thing, so that is minus root 3a plus b y and a plus root 3b x. This quantity was coming out to be minus 8abxy, so minus of that will become plus 8abxy. So actually it's a slightly tricky one where you have to actually try and factorize this. So what we are getting is, let's call a plus root 3bx as p. We call this as p and this as q, and this as r and this as s. We have pq minus rs minus, here we have root 3a minus b, y is r, and we have this is a minus root 3 is rq minus root 3a plus b is s, and this is p. We have this, right?
Yes.
So that is equal to pq minus rs minus rq plus ps. So obviously p common q plus s minus r common q plus s. This is equal to p minus r into q plus s, right? So what we will say now is that this big thing, these three terms are actually p minus r. P minus r is this a plus root 3b x minus r, which is root 3a minus b y. That is one line, p minus r, and q plus s is the other line, a minus root 3b x plus s, which is root 3a plus b y. This is the product. This is the factorization of this expression. Okay.
Yeah.
Obviously it's not easy, but we have got the factorization. So if we got the factorization, we know the two lines are this and this. Once you know the line, you know the slopes, right? Y is equal to mx. Correct?
Yeah.
So
Yeah.
if you know the slope of this line and slope of this line, and you know the third line was ax plus by plus c is equal to 0, then you know the slope of the third line also. You can prove that the angle between any two of them will be 60 degrees. If you prove that, then the triangle becomes equilateral, right?
Yeah.
This is a little too hard for this stage. It's fine. We'll ignore it. But in general, if you have a pair of straight lines, you want to factorize it. Factorize it or solve it by quadratic formula. Here, something weird was happening. I feel like I was making some mistake or something where it was coming negative, which doesn't make sense. So I tried factorizing then, but you can ignore it for now. This is a little too advanced. I don't think like this any question can come for you. Let's look at question number 19. Question number 19 is asking us what loci or locus, what locus is represented by the equation, equation is this: x square minus a square whole square, x square minus b square whole square, plus c power 4 y square minus a square whole square is equal to 0, right? So what does this equation basically represent? Correct.
Yeah.
So if you think about this equation, like notice that this is a perfect square, right?
Yeah.
And this is also a perfect square, right? Correct.
Yes.
So the sum of two perfect squares is equal to 0 only if each of them is equal to 0, right?
Yes.
So we have to have either this, both of them have to be 0. So you have to have x square minus a square whole square multiplied by x square minus b square whole square is 0, and you have to have c power 4 y square minus a square whole square is 0, right?
Yes.
So you can factorize this and you can say that this is x plus a, x minus a, x plus b, x minus b is equal to 0, removing the square, and you can say here y plus a, y minus a is equal to 0, right?
Yeah.
So from this we get that it is possible that x could be plus minus a and plus minus b, and from this we get and y must be plus minus a, right?
Yeah.
So basically, since both of them have to be satisfied simultaneously, like both the conditions have to be satisfied simultaneously, we will get, actually here we will get 8 points, right, which are different combinations of these. Like there will be 4 points from these two and 4 points from these two, right?
Yeah.
You will get plus minus a, plus minus a. There will be 4 possible combinations here, and plus minus b comma plus minus a. There will be 4 combinations here, right?
Yeah.
So basically, this locus is actually just 8 points.
Yes. Yeah.
Okay. Question number 23, for example. 23 is more like the kind of questions that you might see. So 23 is saying, show that the equation bx square minus 2hxy minus 2hxy plus ay square is equal to 0 represents a pair of straight lines, represents a pair of lines which are perpendicular or right angles to the pair of lines ax square plus 2hxy plus by square is equal to 0. So basically there are two different pair of lines, and you have to show that one of both of these are 90-degree to these lines, right? Correct.
Yeah.
Okay, so in order to do that, here we can say that let these lines be y is equal to m1x and y is equal to m2x, right? Because notice that the equations are homogeneous equations, right? This is an homogeneous equation in x and y. There is no first degree term or there is no 0-degree term. So it has to be straight lines that pass through the origin. right? We have seen that if the equation is homogeneous, then the line pair is a line pair passing through the origin.
Yes.
So we already know the condition m1 plus m2 should be equal to minus 2h by b. So it will be here 2h by b. 2h by ax square plus 2h by a here. Why am I saying 2h by a? Think about it. Our standard formula was this, right? Standard formula was this, no? For the
Yeah.
2-degree equation. In this one, we used to say m1 plus m2 should be equal to minus 2h by b. So here 2h was the coefficient of xy term and b was the coefficient of y square, right? Correct.
Yeah.
Now here, the coefficient of xy term is minus 2h, right? So we'll say minus of minus 2h by coefficient of y square here is a, right?
Yeah.
So m1 plus m2 should be 2h by a, right? By applying this formula. Because the equation looks a little different, no? There is a minus 2h and there is a is with y square rather than with x square in the general equation, right?
Yeah.
You understand what I'm saying?
Yes.
You can even solve it and get it, but solving will be longer. So you should know how to get m1 plus m2 directly by looking at the equation. And then
Yeah.
m1 m2 in this equation used to be m1 m2 was a by b here, which is coefficient of x square by coefficient of y square. So
Yes.
m1 m2 here would be b by a, right?
Yes.
So m1 m2 is b by a, m1 plus m2 is 2h by a, right?
Yes.
Okay, great. So what is the line perpendicular to these lines? So if I make new lines which are perpendicular, I will get one line like this minus 1 by m1x and another line like this minus 1 by m2x, right? Correct.
Yes. Yeah.
These will be two lines that are perpendicular, no? Correct. So your m3 and m4 will be basically the slopes of these two lines are m3, let's say it is minus 1 by m1 and m4, let's say is minus 1 by m2, right? Correct.
Yep.
And since this line pair is being represented here, right? So
Yeah.
we will have m3 plus m4. We have to calculate m3 plus m4, which is equal to minus 1 by m1 minus 1 by m2, which is equal to m1 m2 minus m1 plus m2, right? So
Yeah.
this becomes m1 plus m2 is 2h by a, so this is 2h by a minus divided by m1 m2 is b by a. So notice it is becoming minus 2h by b, right?
Yeah.
m3 plus m4 is becoming minus 2h by b, right?
Yes.
And m3 into m4 will be 1 by m1 m2, right?
Yes.
Which is going to be a by b, right? 1 by m1 m2 is a by b. Correct.
Oh, okay.
m1 m2 is b by a, no? So m3
Yes.
into m4 is 1 plus 1 by m1 m2, right?
Yes.
So now this straight line, we know this is standard form only, so we know slope of whatever is the slope of these lines, the slopes should be m1 plus m2 should be minus 2h by b, which is coming here, no? And m3 m4 should be a by b, right?
Yes.
So basically we took the perpendiculars to these lines and we are getting the right equation here, right? The correct equation we are getting same equation, no?
Yes. Yep.
Are you understanding?
Yes.
Okay, so this is basically the theory of pair of straight lines. Now what we need to do, straight lines and pair of straight lines is done. So any line type of questions, we'll do problems later. Right now, I'm just covering the theory so that you know everything that is required. So this part is done. Now what we have to do is circles, parabolas, hyperbolas, and ellipses.
Yes.
So I will quickly give you a brief intro to circles. and then we'll complete it in the next class. Okay. So
Yes.
circles, basically, we know the definition of a circle. We know that the circle is a locus of all points which are equidistant from a fixed point, right?
Yes.
Equidistant from a fixed point. So that fixed point is known as the center, and the distance is known as the radius, right? This fixed point is the center of the circle, and this distance is the radius, right?
Yeah.
Correct. So if I want to write the equation of a circle, let's say the center of the circle is at point h comma k, right? And let's say the radius of the circle is r, correct? Then let's mark out hk here and let's make radius r. Then circle will be the locus where you rotate the thing across the 2 pi 360 degree, right? So I want to find the equation of this circle, right? So the condition that you can write here, the condition you can write is that if any point p, if any point p x comma y lies on the circle, then obviously distance of p from the center hk should be equal to r, right?
Yep.
So we can say distance pc should be equal to r. So we can say distance formula of pc, which will be x minus h whole square plus y minus k whole square, should be equal to r, right?
Yeah.
So squaring this, you'll get x minus h whole square plus y minus k whole square is equal to r square, right?
Yes.
So this is my basic equation of a circle. This equation of a circle tells you the center and the radius immediately, right?
Yes.
If I give you an equation looking like this, x minus 1 whole square plus y minus 2 whole square is equal to 8. I know that the center is 1 comma 2 and the radius is root 8, right?
Okay.
Because basically take square root on both sides. It just means distance formula from 1 comma 2 is equal to root 8, right?
Yes.
So 1 comma 2 must be the center and root 8 is the radius, and you can go anywhere such that this distance is fixed, right? Correct.
Yes.
So
Yeah.
the most simple equation of a circle is this: x minus h whole square plus y minus k whole square is equal to radius square, right? This tells us that center of the circle will be at h comma k and radius of the circle will be equal to r, right? Now,
Yeah.
if I expand this equation a little bit, let's see what happens. It is x square plus h square minus 2xh plus y square plus k square minus 2yk is equal to r square. And rewriting it on one side, we get x square plus y square minus 2xh minus 2yk plus h square plus k square minus r square is equal to 0, right?
Yeah.
Correct. So notice that this is also a 2-degree equation in x and y, right?
Yes.
So we told you earlier that any 2-degree equation, in general, it could also be a circle. So look at this. This is also a 2-degree equation, and this is actually a circle, right?
Right.
So what we will see is what is the condition for the 2-degree equation to be a circle, right? So notice here the condition, one condition is obvious. See, coefficient of x square and y square are the
Yeah.
same, right? Correct. So
Yeah.
the coefficient of x square and y square are same, and there is no xy term.
Yeah.
No xy term, and coefficient of x square is equal to coefficient of y square, right?
Yeah.
So that is actually the condition. So if you have a general equation like this, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, right? This is the most general possible 2-degree equation. Here, if I have a is equal to b and h is equal to 0, then it is a circle.
Yeah.
Okay. So
Yeah. Okay.
let's see what happens. Like if someone gives you an equation like this, how to find the center and the radius from there. Okay. So
Yeah.
if
Okay.
someone gives me an equation like this, ax square plus ay square, I have made b is equal to a here. Okay. And there is no h term, so I will not write h. I will just write 2gx plus 2fy plus c is equal to 0, right? Correct.
Yeah.
Earlier
Yes.
equation was like this, no, by square plus 2hxy plus 2gx plus 2fy plus c. I have just done the slight change. I have made b is equal to a and I have put h is equal to 0. So in that case, it will be a circle. Okay. So let's say we have this equation, right? Then what we will do here is I will divide by a throughout. So I will get x square plus y square plus 2g by a into x plus 2f by a into y plus c by a is equal to 0. Okay. Correct.
Yes.
And now what I will do is I will do completing the square method. So I will say x square plus
Yes.
2g by ax I will take together and I will add a g square by a square, and later I will subtract the g square by a square, and then I will do y square plus 2f by ay together, y square plus 2f by ay together, plus I will add a f square by a square and I will subtract an f square by a square plus c by a is equal to 0, right? This is the same equation, right?
Yeah. Yes.
And now I can write this as x plus g by a whole square plus y plus f by a whole square plus c by a minus g square by a square minus f square by a square is equal to 0, right?
Yes.
Now let's say x plus g by a whole square plus y plus f by a whole square is equal to g square plus f square minus ac by a square, right?
Yeah.
Correct.
No.
I've just brought it on the other side, right?
Yep.
And now we can write this part as actually x minus g by a whole square plus y
Yes.
minus f by a whole square is equal to root over g square plus f square minus ac by a square whole square, right?
Yep.
Now this looks like the earlier thing that we had written, no? X minus h whole square plus y minus k whole square is equal to r square, right?
Yes.
The only thing is that h is equal to minus g by a, k is equal to minus f by a. So hk was our center, and now center has become minus g by a and minus f by a, right?
Yes.
And radius was this thing, right? Correct.
Yes. Yeah.
In general, you will see circle equations will generally be written like this. You will take a is equal to 1 and you will write the equation like this: x square plus y square plus 2gx plus 2fy plus c is equal to 0. And here your center will be minus g comma minus f, and radius will be root over g square plus f square minus c. How are we getting that? We will just do the same thing. We'll complete the square here. We'll say x plus g whole square minus g square plus y plus f whole square minus f square plus c is equal to 0, right?
Yes.
And we'll say x minus g whole square plus y minus f whole square is equal to g square plus f square minus c, right?
Yes.
So now this looks like center radius is given, right? Center is minus g minus f, radius is this root of this, right?
Yes.
Correct. So this is general circle equation. general circle equation in 2 degree. The simpler version of this equation is x minus h whole square plus y minus k whole square is equal to r square. It's the same thing. Here, something else is clearly visible to us. Here, center and radius are clear to us. Here, you have to actually find it out. And center is this and radius is this. Eventually, you will remember this, okay? Like eventually, these two results are standard, okay? So
Okay.
looking at the equation, you can tell center and radius of the circle. So this is my general circle equation. Now, there are some special types of circles. If you have a circle centered at the origin, circle center at origin, radius is r, then obviously my equation will become x minus 0 whole square plus y minus 0 whole square is equal to r square, right?
Yeah.
So this is the simplest circle equation. Circle centered at the origin. So in that case, notice that your g and f should be 0, right?
Right.
Okay. So far today, what we have seen is this general equation has become two things: pair of straight lines and circles, right? It could
Yes.
be a pair of straight lines, and remember, we got the condition for it to be a pair of straight lines by solving for y as a quadratic, then saying that the thing inside the root should be a perfect square, right?
Yes.
The thing inside the root that was a perfect square, and the condition that came out of it was abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. If this is true, then it is a pair of straight lines. And when is it a circle? It is a circle if a is equal to b and h is equal to 0. Okay.
Okay.
So now, like, two things are known. We will discuss more about circles in the next class, and then we'll slowly move on to the other types of curves. But what you should do is just read up a little bit of the chapter on circles. Okay, this chapter
Yes.
will be easy to understand. Chapter 8, you will be able to understand it easily. Just read it a little bit, you will get it what is happening. So
Okay.
we will do circles, we'll do a little bit of tangents and all, and we'll do power of a point and stuff. We'll not do everything in the chapter. We'll do only stuff that is more or less relevant for you.
Okay.
But the first few sections are definitely relevant. So go through that a little bit, and we'll finish off circles in the next class.
Okay.
I'm expecting it will take like three classes or 4 classes maximum to finish off your all the curves. Okay. So
Okay.
by October sometime we'll be done. Then we can do the practice problems or other topics that you want for the exam. Okay. I'll see you next week then. If you have any problems and all, doubts and all, collect them so that we can discuss them in class. Okay.
Yeah.
Okay. Bye.